So let me do a summary of the hybrid predicate calculus, which, as I said, is sort of a combination of different logical systems of importance to computer science. The idea is that we have all these features and they live harmoniously together. So this is the recursive definition of what an HPC formula is. And HPC formulas, they're not necessarily truth values. They define relations, which may be about have arbitrary large arity, or maybe zero arity, be truth values. So first of all, any relation formula, which is an upper class, which for us is upper class Roman letter, is itself already a formula. We can take any Boolean combination of formulas, not just Boolean combinations of letters, but formulas formed any other way. We can combine them together using the usual Boolean things. I won't give them all. Here's a disjunction, here's a difference, and always remember that 0 and 1 count as Boolean combinations of whatever you're combining. Then there's the next feature of the language, if you want, is application, which means that you can say that the property or the relation defined by a formula applies to an individual. Now, notice that you can only give one letter at a time. That isn't really a restriction because this whole thing is a formula, so you can stick another letter in front of it, and that's how you say that Socrates lets Plato. But for the syntax, you only have to do it one at a time. You have the sort of converse of this called abstraction. So if f says something about x, this abstracts it into a property. For those of you who've taken 330, this is really just a disguised form of the lambda operator. You think of it as lambda x, f, blah, 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 blah. Then there's universal generalization, just as we've had in the universal calculus, except these can be arbitrary formulas, so they may have generalization brackets around them, and that's how you can say everyone who likes some Athenian. This is existential generalization, same comment. These can be arbitrarily formulas. Now, we mentioned last time that if you have abstraction, you can pretty much say whatever you want. Technically speaking, it has the same power as first-order logic. If you don't have abstraction and don't want to use bound variables, because they do complicate things, then there's certain things you can't say. We discovered you can't say that someone likes themselves, so we introduced the diagonalization operator. You can't do the passive voice. You can say 1 likes 0, but you can't say 1 is liked by 0, so we introduced the converse operator. And it turns out all you need is one more, plus this meta operator. This one is really a bit bizarre, so let me just introduce it by describing these slightly more technically. If L says that 1 likes 0, this says that 0 likes himself. If this says that 1 likes 0, this says that 1 is liked by 0. And what this one says, if L says 1 likes 0, what this says is 2 likes 1. So it's sort of an odd thing. It increments, it sort of shifts, it puts everything, it's like second-hand speech. Well, Jones told me that blah, 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 so everything is done at one step removed. So you can think of this as indirect speech operator. Now, the thing is, abstraction really is extremely powerful because without abstraction, these still aren't quite enough. What you have to have is one meta operator, which denoted with prime I call shift. And what that does is whatever Q does with respect to, say, 3, 2, 1, and 0, Q prime does shift it over, so it does with 4, 3, 2, and 1. Now, this I'll explain, I haven't explained that, I will be explaining that.